How to solve NMR spectrum? Some steps to solve the NMR spectrum. First of all, we will calculate the number of the peaks. Then we will determine the chemical shift value, find the integration value, and then at the end we will deduce the structure. So here you can see that first of all we will see the IR spectrum, and it is taken in potassium bromide disc. This peak, that is almost 2249. This peak shows that there are the functional group present like C double triple one or C triple one N functional group. We'll see the mass spectrum. This spectrum shows that the molecular formula is C4H4N2. It means that N atom is present in your structure and not one. In fact, two nitrogen atoms are present here. Okay, next this is the C-13 NMR spectrum. This is the C-13 NMR spectrum. As you can see here, first this is taken in the depth, and here you may show that CH2 group shows that your peak will be in downward direction. It means in your structure CH2 group is present. And here if you see this peak is in line with this downward peak. It means this peak is due to the CH2 group, as you may show here, and it is proton decoupled spectrum. And here if you see, one more peak is observed, that is almost at 118 ppm value. This peak is due to the, as you have already discussed as we have already discussed in IR spectrum, that C triple bond C functional group or C triple bond N functional group may be present, and in the mass spectrum you determine that N group is present, and here this value shows that C triple bond N group is present, and this proton decoupled peak is due to this carbon atom which is directly attached with the nitrogen atom having the 3 bonds. It is almost confirmed that this C triple bond N group is present. So now we will talk about the proton NMR spectrum. As you can see here, this ppm value, that is almost about 2.6 ppm. So what about this chemical shift? Which type of the protons it represents? If we go to the ppm value, here you may see that the carbon atoms that is directly attached with the nitrogen means C triple bond N, and the carbon that is attached with the proton. This structure represents the ppm value at about 2.1 to 3.0 ppm value. And here you may see that this 2.6 ppm value comes in this range where it now here this ppm value tells you that your cyanide group is directly attached with the carbon that is attached with the proton. But how many protons are available here? As you count the number of the peaks, only one peak is available. It means only one kind of the protons are available. And you have seen the molecular formula of the compound, that was C4H4N2. This is the molecular formula. It means that here 4 hydrogens are present that are of same kind. So one type of the hydrogen is here, and here one more hydrogen is present. And now all the 4 hydrogens are of same chemical environment, and there are also 2 nitrogen atoms. It means 2 cyanide groups are attached on either side of the carbon atoms that are attached with the proton, so that these 4 types of the protons now will have the same chemical environment to give a single peak. So this is your structure CH2 that is attached with cyanide. This is 1, 2 cyano ethylene, and it gives a single peak in NMR because of the protons that have the same chemical environment, and the two type of the signals are observed in C-13 NMR spectrum to the CH2 and C-111 N group. And if you like my videos, then please share my videos and subscribe my channel. Thank you.